Our first speaker today is Dr. Steve Knick. He's a research ecologist with the USGS Forest and Rangeland Ecosystem Science Center in Boise, Idaho. His research for the past 18 years has been conducted in shrub steppe landscapes throughout the western United States. His studies investigate the spatial and temporal dynamics in shrubland ecosystems with a focus on the role of human and natural disturbance in shaping bird communities. He developed the SageMap website, the primary web-based portal for spatial data and information for research management on sagebrush ecosystems. He was one of the primary authors on the range-wide conservation assessment for greater sage-grouse and sagebrush habitats used by the U.S. Fish and Wildlife Service as part of their decision on listing petitions for greater sage-grouse. Steve today will be presenting his talk entitled Sagebrush Steppe Restoration from an Ecological Perspective. What is success and how will we know it? Steve?
I predicted a couple of years ago, and I made a wrong prediction, when the Fish and Wildlife Service decided that greater sage-grouse should not be listed as endangered under the Endangered Species Act. I predicted a lot of groups would declare success and go home, and that whatever was causing the issues at the time and the problems, declines in sage-grouse numbers and the changes in sagebrush habitats, would continue to happen, and that, again, there'd be no more interest in sagebrush habitats after that decision was issued. And a conference like this and the attendance like this encourages me, and I'm very glad to be wrong in making that prediction. A couple months ago, I was giving a seminar back in the Midwest, and I had given my biographical sketch to the presenter of the conference, and she pretty well summed up my last 20 years of my career in one sentence. She said, "Well, you study sagebrush. Is that all you do?" my initial response was, some kind of a retort like, "Well, you study birds in hardwood forests. Is that all you do?" But it seems there's enough issues in sagebrush systems that it could span a full career. But when you think about, invasive plant species, altered disturbance regimes, petitions to list species under the Endangered Species Act, land use issues, livestock grazing, energy development, there's plenty of things that are happening in sagebrush systems to fill up a career. And clearly those things have gone awry in sagebrush systems, because now we can add restoration to that list of things that we're concerned about in sagebrush systems. And so this conference is about restoration, and I guess the thing I would ask you is, to what are we restoring sagebrush habitats? So I want you to just think a little bit. This is a vision thing. Think about your ideal sagebrush habitat and what that looks like. And if you just come up with a blank, don't worry, I'm here to help. And hopefully by the time we get done with this, we'll all have a vision. And one of the things I want to show you is that how that vision that you have may integrate with some of the other things. And also, I'd like to share with you how I view sagebrush systems from the perspective of a landscape ecologist, which is, I think, very different sometimes than the way many people, particularly those in the traditional rangeland sciences, view sagebrush systems. Because the things I deal with and what I'm going to try and get across today are the way these systems operate in space and time. And the rangeland typically operates in time, in that you have a system now and you do some kind of a treatment, or you have some kind of livestock grazing regime, and that site changes in time. But what I want to show is that it's not only that site, but how that site interacts with the surrounding landscape, and that landscape interacts with an ecoregion, and so on and so forth, really influence how these systems operate and how that influences then the success of our restoration. So you've still got this ideal vision, or a vision of an ideal sagebrush habitat. I want to talk a little bit about the Fish and Wildlife Service decision on listing greater sage-grouse. And as part of making their decision, they convened an expert panel and did something called a structured analysis. And they had this panel sit down and asked a bunch of questions about the different threats, the level of threats and things like that, and projected those threats then out over 100 years or 200 years. So eventually they got to answering the question, will there be sage grouse here 100 years from now or 200 years from now? And where will those sage grouse where will those strongholds be in 100 years and 200 years? So already we've gone from maybe your ideal vision of a sagebrush habitat to something 100 years from now. And what I want to show is that what we do today really is going to influence what that vision is going to be like 100 years from now. But that we also have to be thinking that far ahead, because the dynamics of the system are so slow. We may see some immediate response in the next 5 or 10 years in some of the more productive areas and the higher precipitation areas. But typically the dynamics in some of these Wyomingensis sagebrush systems are 100 years or longer. And some of the projections that have been done with sagebrush habitats and modeling scenarios under different regime or disturbance regimes and different restoration types of strategies project that it's going to take over 100 years to reclaim some of these areas from which sagebrush has been lost. So it's going to take time, and we have a large area to think about as well. And so I want to try and tie that space and time together. Now we're going to go some vision things, and it's basically a couple of pretty slides is what we have. And what I want to try and get is in your head a picture of what you might be thinking is an ideal sagebrush habitat, maybe someplace like this in central Nevada. Fairly lush sagebrush, understory of forbs and grasses. Some of you in Wyoming, and I know there are a number from Wyoming here today, that may envision a more open system with much more of a understory of grasses and forbs in the system as well. In Utah, some may actually want some junipers encroaching into their sagebrush habitat, and others may want those junipers a little bit farther away up in the mountains. The bottom line is that there are any number of habitats that could be an ideal habitat. And it's this incredible diversity that's important. And we also have to recognize as we move across the sagebrush biome that there is this wide range of different ideal habitat conditions. And that we can't always recreate these conditions from one place to another, just because of soils, because of precipitation, elevation, some of these other kind of gradients that exist across the sagebrush biome. And so when we hear about a highly productive system in Montana or in Washington, for instance, and it's got good numbers of sage grouse that maybe are stable or increasing, and we look at the combinations of what's happening there with forbs and sagebrush and grasses, it's not necessarily possible to recreate that system in central Nevada just because the conditions are different, the climate regime is different. And so we can't always project from one place to the other. And again, it's this diversity of conditions that's important in making up the landscape. I'm guessing that no one, in picturing their ideal habitat, pictured a single sagebrush plant. Anybody do that? I didn't think so. And yet, that is a habitat for a fair number of creatures if you go down to the level of a sagebrush plant, whether it's an insect or some kind of a moth or something else. But again, that sagebrush plant, as I'll show, is as much a component of what we're trying to restore as is the larger landscape. I'm also guessing that I'm the only one in picturing an ideal situation for sagebrush pictures a graphic, and maybe that's because I'm a landscape ecologist or something like that, but this to me also represents what we're trying to achieve in the sagebrush biome. And so we have right away 3 different levels that we're talking about, going from an individual sagebrush plant to the community that probably most of you pictured, to actually the biome. I see some interesting, that's actually a Norse symbol that comes across as a plus minus in the conversion. And so what I want to show is how all these different components fit together, and that in restoring sagebrush habitats, we have to pay attention to these different components. I've talked about success, or will talk about success, and I wanted to do it from an ecological perspective. Even though sometimes I'm pushed into the political and administrative world, ecological success is really where it all happens. Because we can have all these other kinds of successes, whether it's in forming groups, whether it's in a political or administrative decision, but the bottom line in success is whether or not we're going to be able to restore sagebrush habitats. And a lot of that now is driven by sage grouse. And I have to admit, I avoided sage grouse for a long time until I got sucked into the vortex, as I call it. Preferring instead, and if you come to my talk this afternoon, to study shrubland birds instead of sage grouse, which I consider to be much more dynamic and a lot less gaudy. But anyways, we also have to recognize that it is sage grouse. That is what's raised a lot of the attention to sagebrush habitats. And that is what's created this emphasis on sagebrush habitats and the importance in restoring sagebrush habitats. So I want to talk about, from an ecological perspective, just what is success and how will we know it. We have to have some kind of a vision, we have to have some way to get there, and we have to have some way to measure it, to know when we're getting there. So I want to talk from a landscape ecologist perspective, how everything fits together. And I freely admit that I'm not a detail person. You know, I leave it to people like Al Windward and Grant MacArthur to tell you what species and subspecies of sagebrush you're looking at. I leave it to people like Dave Pike to talk about what's the appropriate seed mixes and what are the appropriate indicator species and things like that in the monitoring. And Bruce Rowney can talk about the evolutionary aspects and what kind of soils it's on and your geologic history and things like that. I tend to almost float above that, if you will, in terms of what I do in trying to fit that information together in terms of the larger picture and understanding how the whole system operates from the very small to the very broad-based. My first experience in trying to connect with the people who were interested primarily in other things than what I do, I co-teach a class for BLM on restoration of sagebrush habitats, and I teach the landscape ecology portion. And the very first time I taught that class, no doubt about it, I failed miserably. I failed to connect, and we had gone around the room and asked people what was important to them in that class. And one person said that, well, they had had a plane crash in their allotment, in one allotment, and it had burned a half a hectare plot. And what he was concerned about was what was the appropriate seed mixture and how does he get that half hectare back. And what I failed to realize is that what I needed to do is try and show him how the things that were surrounding that half a hectare were going to have a huge influence on what he did in that half a hectare. And likewise, what happens in that half hectare also influences the surrounding landscape. And that's where I think I failed to connect. And so I've been working on that since then. And hopefully with some of this talk, I'll be able to show you how some of the things that you're interested in particularly fit into this larger scheme of things. Then we'll get into some of the restoration strategies. So armed with this knowledge about how things fit together, how do we design a restoration strategy then that addresses these different components? And finally then we'll get into, what is ecological success? How do we measure it? And what sorts of things do we need to put in place to ensure the feedbacks so that we can measure the success and know it when we actually get there? So the landscape perspective is scales in space and time. And people always talk about scale issues. And in fact, it's become common now to say, well, we didn't look at things at the right scale, or we have this different scale. And scale is, to me, one of the most misunderstood terms in ecology right now, in terms of just exactly what it means. And so I'll try and define that when we get to a following slide. And then I also want to show that context is everything. Because what that means is what you're doing on an individual treatment or an individual allotment, a lot depends on what's going on around that site and how it all fits in. So this graph is going to show up numerous times in this talk, and if nothing else comes through from my presentation that you take home with, if this graph could come through in your mind, I would consider it a success. And it's really nothing major. As you can see, Jonathan Swift in the early 1700s had this scaling issue pretty well worked out, just with fleas and smaller fleas and so on and so forth. And that's the way ecological systems are organized. And they're organized then in these different levels in a hierarchy or nested sort of arrangement. And so that you have individuals and shrubs at the low end, in terms of space, and then as you move up in space, you go to sites and populations, landscapes, ecoregion, species, and biome. Successively larger spaces, but each of these are nested within each of the other levels. The important thing to consider in terms of monitoring that we'll get to later is also the time component. In that the dynamics of things that are happening on a shrub happen very much faster than the dynamics that influence the landscape, ecoregions, and biomes. Where we've gotten into trouble with sagebrush systems is that most of the dynamics that were happening at the time frame of shrubs and sites now are happening with such rapidity that they're changing landscapes. Whereas before, most of the dynamics were down within the landscape or within the ecoregion. Now they're happening up at much larger spatial and temporal expanses. And that's what's causing the problem, and that's what is going to be really difficult to try and reverse as we talk about restoring these systems. So what it was, and what it is, and what's around it determines what it will be. And so we'll take this basin big sagebrush and we'll put it in the context of other shrubs. And for now we're just going to talk only at the low end of that graph with shrubs and individual shrubs. But as you can see, it makes a huge difference whether that shrub is located within other shrubs or whether that shrub is it's isolated within that cheatgrass landscape. So if those two shrubs are sitting in the middle of a largely cheatgrass-dominated landscape, as you can see, it only is going to take a fire or something like that, and those shrubs are doomed. Likewise, if shrubs are sitting in the middle of other shrublands, the dynamics in terms of the resources that are available to it and some of the other things are very much different than if the nutrients are being robbed by a cheatgrass and a high grass component surrounding that shrub. And that makes a difference on the viability of that shrub and the ability of that shrub then to provide habitat for other things, whether it's birds or insects or things like that. And so we have, at the very low end of the scale, then dynamics surrounding individual shrubs influencing a particular shrub. Its environment is going to be influenced by where it is. Similarly, if we take that shrub and put a bunch of shrubs together, we now have something that landscapers call a patch or a site, but again, a homogeneous unit of these shrubs. It's going to make a huge difference whether those shrubs are surrounded by cheatgrass or an agricultural field, or whether they're surrounded by a different matrix of shrublands, riparian areas, juniper areas. Again, the surrounding context around that patch makes a huge difference on the dynamics within that shrub patch. So now we have individual shrubs acting within patches or sites, and the combination of those if you go to my talk this afternoon on the shrubland birds, the combination of shrubs, number of shrubs, and the patch size of shrubs starts dictating what kind of wildlife you may have within that shrub patch. And indeed, it's the trade-off. It's like there's a finite amount of resource, and how you spread that over space is important to determining the presence of wildlife, in this case, sage sparrows. And so you can have, for instance, at the high end, a fairly low density of shrubs, but spread over a large area and get equal levels of probability of occupancy by a bird as if you have a fairly tightly packed shrub patch but a smaller size of patch. But again, it's the dynamics and the configuration and the composition of the landscape that is going to determine then what kind of wildlife is able to inhabit that. And so it's this combination of patches then that collectively form the landscape. And I'm guessing what most of you viewed as your ideal sagebrush habitat didn't get to the point of a landscape. It got to a point of a homogeneous patch. It may have been a large patch. It may have been several hundred kilometers in area, but it was still a patch from a landscape term because it was fairly homogeneous. But it gets a little different in this vision thing to start envisioning a landscape, because a sagebrush landscape has to incorporate different periods in that sagebrush life cycle of disturbance, regeneration, and recovery. And that's the part that's a little tough in restoration, because what we want to do is we want to get to this point where everything is a nice level sagebrush habitat with different understory characteristics. But to have a functioning sagebrush landscape, it's got to include disturbance. And most of our restoration strategies don't include that disturbance component. Because right now disturbance is out of hand in terms of many of the fire cycles that we have. There's much more disturbance than what the system was originally used to. But if we're going to get to the part where we are restoring sagebrush landscapes, we've got to have this mosaic of patches of different age classes and different kinds of disturbance and different kinds of regeneration. And essentially you get a mosaic or a checkerboard. I tend not to think of it in terms of forestry terms where you have this rotation of things in a strictly managed system. But on the other hand, you need to have these different components. Some of these landscapes are more highly fragmented because they include agriculture regions or riparian zones or different non-habitat areas, barren areas. But again, the landscape includes not just sagebrush but different components. This is also where we sometimes get into a little difficulty in terms of describing this. Because in oftentimes rangeland terms, if you give a % cover value, what you're talking about is using a line intercept or something like that. So you're talking 25% sagebrush cover to a rangeland ecologist means that you have 25% of the ground along a tape measure or something like that in sagebrush cover. To a landscape ecologist, % cover means the total area within a large landscape that is dominated by sagebrush. So in other words, you could have a 10 kilometer squared or 10 kilometer by 10 kilometer area, and to me 25% cover of sagebrush would only mean 1/4 of that is covered by sagebrush. And the arrangement of that 1/4 is what becomes critical at the landscape level. And that's why we have this difference in semantics sometimes between the rangeland literature and the landscape ecology literature. Each are different ways of describing what's going on. But again, the landscape includes this mosaic of different patches, and that's what we need to try and achieve. And when you start putting landscapes together, then you can start having species. This is the population distribution of sage grouse. Because sage grouse are what's called a landscape species. And each of these different mosaics and patches are important to sage grouse at different parts of their annual and life cycle. So we need to include different combinations of sagebrush habitats. There is no one single kind of guideline. I know the guidelines have been published and all that, but there's no one set of conditions then that are really important within that landscape. It's the combination of them that becomes important. So if we start putting landscapes together, then those are nested within ecoregions, this being a Great Basin ecoregion. And then ecoregions then collectively form the bio. And what we're going to see then is that change, and measuring that change happens very fast all the way up to the biome where changes again are very long term. So the chuckles always come from people who have children in this age class. In terms of a restoration strategy, I want to talk about the hand that we're dealt, and then proposing a multi-scale restoration, and I'll just pretty much deal with the large-scale components of this restoration. Like I say, other people deal with some of the site-specific kind of treatments and what you do in those cases, and then just touch on monitoring a little bit. Monitoring has a lot of statistics and things like that, and I've always claimed that I'm better recovering from a lack of design than putting any design in place to begin with. But I'll talk about the importance of monitoring. Clearly, the future isn't what it used to be. And if any of you, in picturing your ideal sagebrush habitat, thought we might be able to go back to pristine, it's just not going to happen. Sorry, things have happened so much, and a lot of the parts are missing, that going back to pristine is not an option. One of the big issues is that human population change. People are moving from the Midwest and other regions to the wonderful lifestyle that we have within some of the Intermountain West and other parts of the sagebrush biome. And those people all require infrastructure and things like that. And I can guarantee you that none of this was there probably 50 or 100 years ago. And one of my favorite signs, this is in the Sailor Creek bombing range, it says, "This road crosses U.S. Air Force bombing range in the next 12 miles. Objects may fall from aircraft." The point is that things now are very different than what they were some time ago. And that complicates what we're going to be able to do in terms of restoring sagebrush habitats. And so again, this graph is space-time relationships. And fortunately, in dealing with restoration, we are organized very similarly to the way ecological systems are organized. Now, we have national initiatives. Right now, there's the Healthy Lands Initiative and some of the different components of that all talk about prioritizing landscapes and restoring landscapes. There's the Great Basin Restoration Initiative that's going on in terms of restoring that ecoregion. State and local working groups organized, again, at state levels, at local levels, to deal with smaller issues and restoration strategies. And then you have the site-specific restoration and the treatments that are planned. We are organized in very similar ways to the way ecological systems are organized. And just like at the national initiatives, I would hope they aren't singling out individual parcels of land for restoration. We need to be able to understand how site-specific restoration then fits into the larger picture. So to do that, one of the big questions is, this is a huge challenge in terms of restoring many of the areas in the sagebrush biome. Where do we begin? We do not have the resources, whether it's financial, logistics, personnel, seed sources, any of those kind of things, to be able to just go out and do everything at once. So where do we begin? Whose area is the most important? If not the most important, where do we start? And so one of the things that Dave Pike and Karen Meinke and I did is we did some predictive modeling to try and prioritize which regions should be first on the list in terms of where we would focus our effort. So now everybody's on pins and needles. Is my region going to come up in terms of being a high priority area? What we did, the set of criteria, is we looked at the sage-grouse distribution. These are the criteria then that are important in terms of management as well as in an environmental or ecological way. Where are the sage-grouse distributed so that we could focus restoration in those areas where they're going to do the most good to benefit sage-grouse? What is an optimal sagebrush environment? Where's the precipitation, the soils, soil characteristics? Where are those ideal to grow sagebrush? So we're not putting a sagebrush habitat out in the middle of nowhere, in a place where it's not going to really thrive. Our probability of actually growing sagebrush isn't the optimum. We also looked at landscape components. We tried to pull in this multi-scale kind of thing in terms of where within the landscape should we focus efforts so that there already is a fair amount of sagebrush there. But it's in a fragmented condition, so we can increase the connectivity, we can increase the amount of sagebrush in that area, provide corridors, and improve overall the sagebrush habitat and dynamics of those systems. So we took, again, this multi-scale component, and then we also modified it based on where cheatgrass might be an issue, so that we wouldn't put a restoration treatment in an area where cheatgrass might come in and really confound our likelihood of success. And so we came up with this set of priority regions. This is the area, we didn't do the entire sagebrush biome, but we did a number of the floristic provinces in the Intermountain West. And again, our whole goal was to identify those areas having the greatest amount of success, so we could avoid restoring habitats and doing treatments in an area that was bound to fail for one reason or another, either because of cheatgrass, because of suboptimal environmental conditions. And so if you look at the high priority areas, there's clearly a lot of places that we could start restoring sagebrush. So all of you, at least in the Intermountain West, probably could take heart from this graph right here, in that most areas it's possible to grow sagebrush. That really shouldn't be a surprise when you look at the original and the historical distribution of sagebrush. It did cover much of the Intermountain West. When you modify it by cheatgrass, in other words, this ability of cheatgrass to come in and either complicate the restoration treatment because you have to do extra steps to control for cheatgrass, or because of the disturbance involved with the restoration treatments, we significantly reduced the area to parts of the Snake River Plain, some of the Owyhee uplands, and parts of some of the higher elevation regions in Nevada. Even this, though, still provides, I think, enough area that we can pick and choose among these high priority areas as to where we might choose to restore sagebrush habitats. What we do in this restoration class for BLM is we start at the very big, and we get to this point where you actually select a single area. At this point, different kind of objectives come in, because at this point you're selecting individual sites. The sites have different kinds of objectives and treatments. And so you kind of trade off in terms of objectives, you trade off in terms of the kinds of treatments that you might do, but you're now putting that treatment in an area where it's going to be the most effective in terms of restoring the sagebrush landscape. Finally, we're going to talk about success. As I said, there's any number of different kinds of successes. Political success, partnerships. I deal primarily and almost always exclusively with the ecological success. The way we will know if we're successful is only if we have appropriate monitoring designs in place. Those designs have to be hierarchical, just like the system is organized, from local to the biome and from years to decades. We aren't going to be able to march back to Congress or someplace else and say, in 5 years, that, well, we restored the biome. We may be able to put back some sagebrush plants, we may have established some treatments, but we aren't going to see those kind of effects show up at the landscape yet. And finally, a valid scientific documentation of the research. And so again, I think this is the last time you'll see this graph, but again, I want to emphasize now the time frame for these monitoring programs. And that most of the treatments that we do, we can probably make measurements on those in yearly or 5 years or even decades. But by the time you get to landscapes, ecoregions, and of course the biome, 10 years probably might be a minimum. We don't have to invest a lot of time into developing some kind of a large-scale program to monitor the landscape on a yearly basis. Some of the larger programs, and we're probably going to have to use techniques like satellite imagery or large-scale coverages to be able to estimate change at these large spatial scales, and we need to time those over long periods to match the rates at which those kind of the landscapes can change. And similar ecoregions, not in my lifetime probably, but 50 years, 100 years is when we can start looking at changes within ecoregions. The feedback is going to be important as we go back in these monitoring programs in terms of an adaptive management to be able to show how things are changing within these systems and how they might affect different levels relative to those systems. The Western Association of Fish and Wildlife Agencies, in their strategy document for sage grouse and sagebrush habitats, lists as their definition of success is to maintain and enhance populations and distribution of sage grouse. That's going to involve reversing declining trajectories of both sage grouse and some of the habitat conditions that are rapidly deteriorating due to some land use issues or habitat change, spread of exotic plant species, things like that. It's going to require stabilizing existing systems and restoring some systems that have gone past the point where we can either stabilize them and restoring the systems. So that, again, is my definition of success too, in terms of restoring all of these systems and the different components within those systems. In summary then, the only way we're really going to manage the restoration and success is to be able to adhere to pay attention to each of these components, which are nested within each other. They're hierarchically arranged. We're organized to be able to restore within each of those components. And I think we can organize also to monitor within those components. And we certainly have developed a strategy with prioritizing in different kinds of land treatments within high priority areas. And the successful restoration is going to depend on addressing all of these levels. This is the current distribution of sagebrush, at least probably around the late 1990s. And it's determined from satellite imagery, and it's kind of using some GIS techniques to give the general distribution of the areas within the landscape dominated by sagebrush. So this is where we currently are. And in terms of monitoring and in terms of the projection, if we take the Fish and Wildlife Service projection, or at least the expert panel projection that was fed to the Fish and Wildlife Service, and take that out 100 years and roll back only to those areas that are the strongholds, this is quite likely what it will look like 100 years from now. Clearly we have a huge challenge ahead of us if we are going to be able to reverse this trend, to restore systems, and improve upon this projection. So with that, I'd like to thank you for trying to understand how these systems operate in space and time. There have been a number of people and organizations who have supported me and my thinking and work, and so I'd like to thank them for the support as well. And I believe we have some time for questions, correct?
Yes, you mentioned you emphasized the importance of monitoring or evaluating restoration systems. Why then is monitoring seem to be such a low priority? It seems to be new. Could you elaborate on that?
The question was, I emphasized monitoring as very important to be able to identify and to feedback in terms of whether or not we're successful. Why then is monitoring often given a short shrift in terms of programs with the agencies? I don't know that I can answer that for the agencies except to say that you're absolutely correct in that monitoring is one of those things that, yes, we need to do it, but it takes an investment over time. And what often, if I can guess, and I can't pretend to know the mind of some of these agencies, but what we're interested oftentimes seems to be in instant feedback. We've put so many treatments in the ground, we've treated X number of acres, we've restored this amount of thing, it looks like we're doing something. But I believe, as Dave Peichen and others can say, that the long-term monitoring just is not implemented. And I'm not sure why. Maybe someone else will deal with that part of it. Other than that, it takes time, it takes effort, and it takes a resource. And it doesn't always provide the instant feedback. I do know there are a number of monitoring programs being developed. Some in the pilot phase. BLM has several pilot programs for monitoring, one focused in the Owyhee uplands, and I think 2 other areas. One, I believe, is Alaska. And so they recognize the importance of it, and I believe that they're working to develop these programs. There's also a program, the Great Basin Integrated Landscape Monitoring Program, that again is kind of a pilot effort that USGS and a number of the other BLM and Fish and Wildlife Service, Park Service are working to implement. So some of these designs are in place or being developed to try and correct this need for long-term monitoring. Yes?
You did your drill down exercise to identify the best areas, and then you carved out the area with the cheatgrass, and you left these areas that had for restoration. Do you have a marketing problem with that, in the sense that you're actually identifying the areas, the very areas that the agencies would not be willing to touch? Because that's the last one. That people think of resist putting disturbance in a homogeneous landscape of sagebrush. So that's the area where people have the greatest resistance from the agencies to actually do action. Although I agree with you, you need to put disturbance in those systems. So that you try to identify like second-tier systems that have high potential for restoration, but they may have cheatgrass, but there's a chance to recover.
Actually, what we tried to do was maybe the easiest in terms of, we did recognize that these weren't the large homogeneous locations, but there was a fair amount of fragmentation within that. So we weren't going to be cutting up a large landscape, but rather selecting areas that had within the landscape about 50% sagebrush, but it was arranged in a very fragmented, so you could fit in the spaces in between. Where the cheatgrass came in was in terms of a modifier, that there's plenty of places that have this kind of a fragmented condition without the complication of cheatgrass. Let's focus on these other areas to begin with. So I maybe didn't state that clearly enough, that these were areas to begin with that were not large homogeneous areas, but that we were trying to get them to being a more homogeneous landscape of a different mosaic of sagebrush kind of communities. Yes?
Just curious on that prioritization map, if that was available on your SageMap website.
The question was if the map of prioritization areas would be available on the SageMap site, and we are going to put it there. We've just gone through the last iteration on a publication with that, and so now that we will put that and make it available not only as just a PDF or graphic, but also in a GIS format. Yes?
2 questions. One is, can one species really be the measure of restoration for an entire biome? And the other question is, on your map 100 years out modeling, what kind of climate change did you factor into that?
The first question on whether one species can be a measure of change in the biome, if we define, you're correct in that there are many other elements within the biome. We define the sagebrush biome, which is not a single species, but a large number of different species across the biome, as the habitat that we focus on. But recognizing that once you get to the biome level, what happens in some of the forested regions adjacent to sagebrush habitats or to riparian zones within that biome, or even agricultural systems, is going to have a huge influence on sagebrush habitats within that biome. I don't know if that answers your question on the species. The next question was, can you refresh?
When your map projecting 100 years on your model, what kind of climate change?
We didn't incorporate climate change in that. It may reflect some of the climate change conditions in terms of some of the projections for climate change are that we will have an increasing amount of significant weather events, all of which in fire intervals, things like that, all of which is likely to promote cheatgrass expansion and loss of sagebrush habitats. So we've shrunk the projection back to only those areas in which are largely dominated by sagebrush in the extreme optimal environments today. It may not project major climatic shifts that would cause it to move upslope, but again, many of the dominant sagebrush habitats are not these low elevation systems anymore.
Any more questions? All right, thank you.